Jeremy Blum is the Director of Engineering and Lead Electrical Engineer at Shaper, where he architects and designs hardware and software for augmented reality robotic power tools. Before joining Shaper, Jeremy was a lead electrical architect and engineer at Google X, where he worked on confidential products including Google Glass. Jeremy received his bachelor's and master's degrees in electrical and computer engineering from Cornell University. Please welcome Jeremy Blum.
Hi everyone, my name is Jeremy Blum. I'm the Director of Engineering at Shaper, where we make robotic power tools. As our startup has grown over the last 5 years, I've had the opportunity to wear a lot of hats there that are tangential to my core role as a system architect and electrical engineer. Today, I want to share some of those learnings as they relate to your product supply chain and manufacturing needs. So the goal of this talk is going to be to convince you that taking a more proactive role in supply chain and manufacturing decisions can reduce your product's time to market, reduce your workload, and reduce your product's end cost and sustaining engineering costs. This is all coming from my perspective as an electrical engineer and a system architect, someone who probably shares a lot of technical background with many of you who are listening, but maybe don't have as much experience on the manufacturing or supply chain side of things. So we'll go through a bunch of things that I've shown here, but to start off, let me tell you a little bit more about myself so you understand where I'm coming from and how I've kind of gained this knowledge that I'm trying to impart to you today. So my time in both academia and industry has enabled me to work on robotics, wearables, prosthetic hands, digital fabrication, home automation, engineering education, sustainable energy systems, and a lot of other stuff. When I'm not designing products, which is my core focus, I really like teaching people. I released the second edition of my popular textbook, Exploring Arduino, late last year. And it has an increased focus on a lot of the areas relevant to product development that I've learned at my time bringing products to market at Google and more recently Shaper. I have found that there's a tendency to decouple engineering work from manufacturing and supply chain business development. And I think that decoupling is detrimental to robust business and product development. So that's a lot of what I want to talk about here. I'm not going to go through all the things I've worked on, but I am going to, in the next few slides, highlight some of my experiences in academia, working on consumer hardware at Google and now at Shaper, and how those experiences have shaped my personal approach to electrical product design. My trajectory in my career thus far has exposed me to some ways of thinking that I think are generally not common amongst engineers, but I have found have enabled me to build more innovative products and to have my voice as a design engineer heard when it comes to product definition, manufacturing, supply chain, how we market to consumers, things like that. And those are some topics that I've touched on in talks that I've given at the last 2 AltiumLive conferences. So if you want to learn a little bit more about that side of things, I would encourage you to go watch those talks. So I got my undergrad and my master's in electrical engineering from Cornell. This slide is just a few highlights, but while I was there, I did research on 3D printing, evolutionary and bio-inspired robotics, LED lighting, solar power, net zero home technologies, and a bunch of other stuff too. Through these experiences, I was very privileged to work with people who had a very different way of looking at the world than I did. And this, again, is something that I've touched on in previous talks. I worked frequently with artists and architects, and it was really working with architects on the design of some green building stuff that we were doing that I first learned to appreciate perspectives other than my own. My engineering courses taught me a very linear design approach. You collect data, you analyze the hell out of it, develop a plan, and then execute on it, which is great. But in working with my architecture peers, I learned to appreciate a more fluid form of thinking about the design process. I learned how to fail quickly, rapidly prototype, and the importance of deeply understanding the end customer to your product, whether it's an internal customer or an external customer. So after college, I spent a few years at Google X, where I mostly worked on Google Glass. I led system architecture design for a couple of products there, and I was a technical lead on the electrical design for Google Glass Enterprise Edition. So a lot of people know the story of Google Glass and how it maybe didn't do so great in the consumer market, but the Enterprise Edition of the product, which is what I focused on, I believe is still being sold and used in businesses around the world. Actually, I think they released a new version pretty recently. But companies like DHL, GE, Samsung, they use it in logistics, manufacturing applications, and it's used in hospitals for healthcare work, which is what this animation shows here. So this product was very hard to design and manufacture, as one might imagine. I'm sure a lot of you are also working on wearable products that are really integrated and hard to design. All the electronics and glass were so tightly coupled with mechanical requirements that actually all the patents I have for glass are really all electromechanical in nature, not just electrical. There was a lot of interdisciplinary communication that happened on this product to make it manufacturable. Even at Google, which is viewed as one of the most innovative companies in the world, I found that people could kind of be pigeonholed into their respective areas of expertise. And it was useful to be surrounded by experts that were focused on things like manufacturing, supply chain, reliability, etc. But I personally wanted to have a more holistic view of the product introduction process. I really wanted to touch every element from conceptualizing the product to selling it to customers. And so I learned a lot from the various experts at Google about those other topics, but just bits and pieces, and then had an opportunity to see more of the whole picture when I went to Shaper. So now I'm at Shaper. Many of you have probably heard me discuss Shaper before if you've heard me speak at previous Altium conferences. I've been at Shaper for about 5 years now, almost 5 years. And I was one of the people tasked with taking this concept from a prototype into something that was actually manufacturable, distilling the features and bringing it to market. Origin, our first product, is a handheld robotic CNC machine. Basically, you select your design to cut, and in 2D or 3D CAD software, you can design it, or you can pull down designs from Shaper Hub, our website of design resources. Origin digitally then augments your workpiece, and then it's basically like playing a video game. You follow the lines on the screen as best you can, and Origin makes the fine adjustments for you in real time. It's basically autocorrect for your hands, and you can see in the video here how that works. So Origin's been on the market for a few years now. It's the only power tool in the world that gets better the longer you own it. I manage our awesome embedded software team who, working with our product development and customer-facing roles, developed over-the-air software updates, and they constantly enable new features for Origin. It's part of an expanding ecosystem of products that make it easier than ever to build things with Workstation and our online ecosystem of designs. Okay, so you know a little bit about where I'm coming from now. You know that I have kind of a keen interest in this multidisciplinary design work and touching a lot more than just the electronics. Now I want to recap the last topic that I talked about in my 2019 Altium keynote. So this was the last section of my previous keynote. And I call that design for humans. So we often talk about DFM, design for manufacture. Design for humans is kind of like that. Basically, before you can effectively start leveraging your engineering expertise to better understand your supply chain, you need to consider all the people that touch that supply chain and how they interact with your designs. So I want to touch on that first. So when I say DFH, there is actually 4 types of humans that your documentation as a design engineer should cater to. The first and most important is yourself. How many times have you made a decision that made perfect sense at the time, and then you come back to it a year later and you're like scratching your head and like, why did I do that? When you write your documentation for yourself, you naturally double check your work and you identify problems you've introduced along the way, and you make your future self happy. The second type of humans is customers. Whether this is an internal engineering team or you're building a mass manufactured product to be sold around the world, electronics are going to play an important role in how they experience the product as a whole. If the electronics are overheating or damaged in some ways, there's some mechanism in which this can be communicated to the end user. The third is your coworkers, both technical and non-technical coworkers. So, give a man a fish and he'll eat for a day, teach a man a fish and he'll eat for a lifetime. The same thing, same adage applies to your coworkers. If you integrate meaningful documentation into your schematics, your block diagrams, fabrication packages, and then teach your peers where to find and how to use that information, maybe you have an internal wiki or something like that, you're going to be teaching folks like the embedded software team, for example, how to find that useful information in your schematics and how to leverage that in their work. This means generating detailed BOMs for your sourcing team, being involved in their negotiations with vendors and suppliers, giving the information you need to the other engineers in your team, and they'll be able to hopefully reference that documentation that you've generated for them, and that gives you more time to focus on the design work. The last thing is your external partners. So these are your manufacturers, your distributors. The most important thing here is that these people are an extension of your team. If you treat them with respect and give them the information they need to do their job with minimal clarifying data from you, they're going to be most effective. If everything is documented in your fabrication and assembly drawings, it might take longer to actually make those drawings now if you make them really detailed, but in the event that you do need to change suppliers, for example, later, it's going to be way easier for you to do so. I personally never allow my fabricators to make fundamental changes to my Gerbers. If they need to use a different stack up than I've specified, then I'll review it and update it in my fabrication documentation, for example, and then provide that back to them. This sometimes takes a little bit more time up front, but part of what we're going to talk about in the remainder of this talk is why it's useful to spend that time up front and how it actually ends up saving you time in the long run. So when we're talking about designing for yourself, this means making an extra effort to make your job easier. Provide opportunities for how to modify your designs to test them in ways that you know you might need to. This means 0-ohm resistors, jumpers, test points, things like that. It also means putting silkscreen indicators on boards where you have room for them that might give you hints so that you don't even have to whip out your documentation to decide how to do something. This example on the screen is a board we use on our manufacturing line to drive a motor, do something simple. When we first designed it, we didn't know what microstepping mode we were going to drive the stepper motor in, so it's designed to support all of them, and a simple modification allows you to pick between them, and the documentation to do so is written right on the board itself. When it came time to implement this board, it was way faster and easier for me to bring it up because I had designed this months earlier and had already forgotten, half of the details about the design, but the information was right in front of me. When we're talking about your customers, it's about understanding the environment that your customers are going to use your product in. We design Origin to withstand brutal workshop environments. We know that certain error states are going to be unavoidable, and so we integrate sensors to make it feasible to display those in a meaningful way to the end user. When we're talking about your coworkers, use Altium's drawing and notes functions to add useful descriptions to your schematics. This is directives to your PCB layout team, GPIO information for the software team, test point info for your manufacturing and factory testing team. And depending on the size of your company or your team, these team members I'm talking about might also just be you. So sometimes this is the same as doing the right design for you as a human. And then your manufacturers and your external partners. Writing good documentation requirements early, taking the time now will save you much more time later. Make your stack up detailed, for example, so that they can't possibly deviate from it because you've called it out so clearly. It might also mean designing test fixtures and instructions for those test fixtures that allow them to kind of help themselves. I'm in California, but I'm working with suppliers and manufacturers on other continents around the world. And oftentimes if there's a problem and they have to communicate back and forth, you end up losing 2 or 3 days just in like the email time zone difference and all that stuff. So if you can provide good documentation in advance that allows them to solve the problems themselves, you're going to save yourself a bunch of time, but you're also going to save time on the timeline of the project as a whole. And don't underestimate the importance of pretty pictures. Even if you're using MS Paint to illustrate information, it's better than just writing text, and it has the added benefit of overcoming language barriers. Okay, so we've talked about designing for humans. Now let's talk about the communication web that kind of follows from that. So this might be representative, what I've drawn here, of the daily types of communication that you're having. Obviously, this diagram is going to vary a lot from company to company based on company size, where the company is in their life cycle, and there's a lot of things that I'm not showing here. But this is kind of a distilled view. So the nice thing about a structure like this is that everyone has a role to play, right? The engineer can largely focus on the design work. His or her coworkers can manage the things that they're good at. Upstream suppliers manage their own suppliers, etc. So members of your team may loosely interact with your designs and documentation, but largely in this configuration, they're just kind of being passed through them to the relevant manufacturer. Your manufacturing team and your supply chain team are kind of helping you ferry data back and forth. So while this can work efficiently when things are in stable production, it doesn't work great for new product integration or new product introduction. This generates inefficiencies when you're up against a deadline to get a new board out, for example. So let's look at this scenario. You're designing a board. You think you're probably going to need 6 layers. You tell your supply chain team, who reaches out to the electronic manufacturing services company, the EMS contract manufacturer. The EMS company works through their broker to identify one of their trusted fabricators that has a 6-layer UL recognized stack up that meets your needs. They share it back to you. Now like 2 or 3 days have passed already. And by the time you receive it back, you've already made further progress in the design, and now you realize you need to be 8 layers. Okay, so now you do that whole thing again. This process repeats and you lose countless days. Another problem that arises from this kind of communication scheme is this one. So your supply chain team provides your preliminary design to the EMS company to get a budgetary quote. Comes back over budget. Okay, so it looks like some of the components that you spec'd in are pretty pricey. And maybe you even spoke with the component manufacturer. You can see here I'm drawing a direct link between you and the component manufacturers in advance, but you weren't really working with the distributors here to find the right cost that fit your product. You're focused on finding the component that meets your technical needs. And while that should be your highest priority as a design engineer, you also need to understand the needs of the product marketing team, the supply chain team as it relates to price. So what I'm advocating is something that looks more like this. When you start coordinating with your fabricator, contract manufacturer, distributors, internal teams earlier in the process, there's fewer delays overall. So this probably seems obvious. I know a lot of you are talking directly to your fabricators, talking directly to your CM, and these people are looped in. But something that I've also seen a lot of, and have been guilty of myself, by the way, too, is that engineers tend to have a kind of like unnecessary desire to be overly secretive early in the design process. Maybe it's because they're worried that their design is still looking messy, or they haven't really coalesced all of their thoughts completely. And that's okay, but even if you give the relevant contract manufacturer the heads up that you're working on a new design and share whatever preliminary info you may have so that you can start the conversation about what the requirements are going to be, it's going to save you a bunch of time even in the next few weeks. There have been a lot of occasions where I've taken an early subsystem design concept to a distributor application engineer or a manufacturer application engineer, and they've given me really insightful feedback that saved me a ton of design time and headache, and I was really glad I spoke with them. Especially at the distributors that you may be working with, there's a lot of smart people there who are, responsible for knowing a lot about the line cards that they represent, and I feel like they often go underutilized. Leveraging them is a really important thing and can save you a lot of time. Through all this, you should keep the members of your team that are responsible for managing your contract manufacturer, your supply chain team, your manufacturing team looped in. But it's useful to be involved directly in those conversations. So this doesn't have to be like super onerous. It can be really helpful to explain your ideas and plans aloud to just like another technical person. Especially if you're in the situation that I was in when I first joined Shaper, where I was the only electrical engineer. Thankfully, I'm not anymore. I just like needed another technical person who understood what I was talking about to just say ideas out loud to. And often you can find that person with your component manufacturers, your distributor, application engineers, your fabricators, and just sometimes saying your ideas out loud is a helpful sounding board that will help you catch problems early. So again, it's not about cutting out other elements in your team here, but it's about involving them and having direct conversations earlier. Okay, so let's talk about the price and capabilities chat if we're talking about you interfacing more directly with manufacturers, CMs, fabricators, component distributors, etc. So the previous slides kind of assume that you already had a well-established selection of manufacturing partners with. Some of you working at larger companies, that may be the case. You know, you're possibly dictated, like, these are the manufacturers we work with, these are their capabilities, these are the constraints you have to work within. Or maybe you're at a new startup and you need to kind of build those relationships for the first time. If that's the case, don't let a sourcing team or whoever is responsible for sourcing, maybe it is you if it is a startup, dictate who the external partners are that you can work with if you can avoid it. The best balance between capability, cost, and speed is going to be achieved by ensuring that you as a designer have a seat at the table from the beginning. So this means you need to be involved in the RFQ process. And I know what you're thinking, that sounds really boring. And there are elements to a request for quote process that can be boring. But it's not difficult to put together an RFQ. If you can assemble a schematic, you can sure as hell assemble an RFQ. And it will give you really good insight into the types of things that influence cost and lead times for your design, which is insight that's useful to have just in the back of your head when you're working on designs later. It's really useful information to have. And the best way to get it is by being one of the people who's interfacing directly with selecting manufacturers and external partners to work with. So you do that by working on the RFQ. So when you're assembling an RFQ for an external partner, like an EMS company, consider some of the following things. What capabilities are you going to need now? And are you going to need different capabilities in the future? You know, maybe you have grand visions for the amount of the quantity that you need to manufacture or the component sizes that you're going to need to be able to handle at some point. Can you and your team communicate with them using the direct communication web that I showed earlier? Or some companies are structured in such a way, like contract manufacturers, that make that very difficult. They really only have like one point of contact. And while it's good to have a single coalescing point of contact, it's also useful to be able to have direct contact to the right technical people when you need it. Another thing that I find useful when preparing RFQs, and you know, if any manufacturers that I've worked with are listening here, it means you've passed the test, is I usually intentionally omit certain details from sample documents. So part of an RFQ is often providing like a data package of, here's an example of a board we would ask you to manufacture. So you give that to them and intentionally leave certain things out. Maybe you leave out the stack up, or maybe you leave out some tolerances on something, or you leave out elements from the bill of materials. Now, a good contract manufacturer, a good partner, is going to understand that those things are missing and then ask them from you. A not good one is going to make assumptions based on whatever their defaults are. And I don't know about you, but for me, that's problematic. I like to have everything well defined on my end. I don't like decisions to be made for me. So that's often a helpful tactic. And whenever possible, quote several companies and compare the pricing and capabilities, both quantitatively and qualitatively. I usually make a spreadsheet matrix to help me with this. And by the way, while you're doing this, there's nothing wrong with being transparent about it. It's okay to tell the distributors and manufacturers that you're quoting with, hey, we're looking for a new partner for this project. You know, we're looking at 5 different companies. You are one of them. Let them know that they're trying to compete for your business. Okay, so you know you need to communicate more directly with the parts of the communication web that I showed earlier in order to increase your effectiveness as a design engineer. But let's focus, I want to focus on one key part of it, which is the components distributors. So these are just, I think, the top 10 distributors, at least as of last year, I believe. But there's obviously a lot more. Odds are everyone who's listening to this has worked with at least 1, 2, or 3 of these on this slide. So there's a question, should you be working with distributors directly? Should you just choose whatever components you want, work with component manufacturers, and then let your contract manufacturer decide where they're going to get the parts from? Somewhere in between. how do you effectively manage working with multiple distributors that are competitors of each other, but are probably all part of your supply chain? So in my view, when you're working with distributors, transparency is key. And I said this earlier too. You want to save money and reduce lead time. They want to win your business. There's both things you can bring to the table here. And as is the case in most business relationships, being upfront with your expectations will make the working relationship smoother and more useful to both parties. There's no reason this can't be win-win. So working early with distributors is win-win for both you and the distributor if you do it right. So let's talk about leveraging distributors for component selection. Have you ever tried to do a parametric search looking for, like, you're certain there's a chip that does this specific thing, but you don't exactly know how to explain it, and you're digging around and you can't quite find the one that just has just the right specs. It operates at the right voltage range, it has the right power consumption, the output is active high or active low, whatever it is for the given thing that you're working on. I mean, it can be daunting. You go on DigiKey and it's, 11 million parts available to look at. Use your distributor to help you find things. So your manufacturer, your contract manufacturer for your PCBAs is going to end up buying parts from one of these distributors anyways. The exception to that is if you are doing super massive quantities, right? Like Apple is buying chips directly from Samsung. They're not going through a distributor to get them. But for most of you, you're probably getting parts through a distributor at some point. And you're going to be working with them anyway, so why not start to form the relationship with them directly earlier? Distributors are incentivized to find products for you that are on their line card, that meet your needs. So if you share your query with multiple distributors, you get the best options, and you should be, again, transparent about doing so. So, it's okay to reach out to your contact at Avnet, at Future, at DigiKey, at whatever, and tell them, like, here, I'm looking for a chip that does this thing, or I'm looking for a capacitor that falls in this price range that has these performance characteristics and is automotive rated. See what they come back with. They all have different items on their line cards. Some manufacturers are exclusive to certain distributors, etc. So it's important to kind of put your request out there to multiple and negotiate pricing early and directly. Distributors want to win your business on a component, but you lose all your bargaining power if you've already made a technical decision to design something in. So before you, or as you're doing that initial design process on your PCBA, start thinking early about what are your price constraints, what are the key components where that's going to be a major driving factor. Focus your effort on single solution parts like ICs that don't have drop-in alternatives, because that's going to be much harder to change later. The other place where it's absolutely so helpful to work with distributors is in managing part end of life and for enabling part obsolescence management. So at the outset of your project, you want to make sure you understand what its life cycle is going to be. When is it going to go to market? When do you expect to retire it? Are there going to be any ultra critical components that you know will be really hard to design a replacement for later? This might be true of specialty components that you have had to calibrate in some way or have had to explicitly build software around. They might be mechanically unique components like switches or buttons that integrate into your industrial design in a very specific way. If you don't think about this plan early and part end of life sneaks up on you, you're going to have a pretty bad time. You want to be focused on design work, not having to go back and forth with your supply chain team all day, consider figuring out how you're going to decide how to solve a problem with a part going end of life. So let's look at a couple of the options if a part does go end of life. And then we'll talk about how the distributors fit into this. So you generally have a few options when a part is going end of life. There's many more than what I've shown here, but here's a few examples of ways you might handle it. So if you're lucky, maybe there's a drop-in replacement. The only cost to you is whatever revalidation work you have to do. This is pretty easy and cheap if you're careful with your initial component choice at the outset, which is part of what I'm encouraging you to do here. So don't choose esoteric packages, for example, if you can avoid it. When you're looking at commodity parts especially, you might be able to just validate an alternative part and drop it in. Ideally, you have an alternate parts list at the beginning of your product development, and so you've already specified a bunch of drop-in alternate parts that can work for various parts of the system. That's not always possible, though. Sometimes you have single source parts. That's the reality of designing complex products today. So another pretty easy option, but probably not the favorite option of your finance department, is to buy as much as you can before the product goes end of life. So basically enough to last through the lifetime of your product, and then warehouse it. This has a bunch of problems. Depending on the type of part and what kinds of quantities you produce, this might be financially impossible because all that money is now basically locked on your books. And until you build those components into products and sell them, that is money from your company that's basically just sitting there. If your product has a 10-year life cycle, this is probably not realistic. If your product is manufacturing in the quantities of millions per year, you're not going to buy millions of these parts and just stock them. I mean, maybe you can, maybe your company can, but I think for most people that's not a tenable option. The highest effort solution is going to be to design in a replacement part that requires a board respin. So this sucks for reasons I'm sure you all know. You have to revalidate, you maybe have to recertify against FCC and things like that, depending on the change. You have to do more quality checks. If the part is going end of life and you can't buy enough parts to keep it going for a while, you might have to do this under a ton of time pressure too, which is stressful and awful. And then the last option is some combination of those last two I talked about, which is you buy a bunch, enough to keep you going for 6 months maybe, and you use that as buffer time to design an alternate solution. Now, generally, you should be getting an end-of-life notice at least 6 to 24 months before a part actually stops being manufactured. So that hopefully should give you enough time to buy some of that buffer. So, okay, how does this apply to working with a distributor? So, like I said before, assuming you're not Apple and you're not buying directly from semiconductor companies because your quantities are so enormous, you likely have no choice but to work through distributors anyway. So they do add costs to your supply chain, but they also add value. And it's easy to not take advantage of that value, but that value is there and you should take advantage of it. So consider on this slide how an effective relationship with a distributor can help you with the previously discussed options that I worked through, right? So if we're talking about a drop-in replacement, they may be able to help you with identifying a replacement and potentially offering inventory help as well. If you're kind of operate on a runway, do a last time buy, and then design a replacement, they may be able to help you hold on to a larger quantity of those parts while you work on that design change. If you have to do a respin, they should be able to help you identify replacement options, because if you were previously sourcing from them, they want to continue having that business from you for that socket on your board. And so they should be able to help you from an FAE design in perspective, but also from a sourcing perspective, help you find an alternate component that should work. They're incentivized to do that. And then if you're going to go the super expensive option of buying as many of a part as you can, your contract manufacturer might not be up for that. They probably don't want to hold in inventory 1 million of a component for you, but maybe the distributor will, and they might offer that as a service for some nominal fee. Okay, so you know how to leverage your distributors more effectively. Let's finalize here by talking about what the weak link is in the supply chain. So just like any chain, it's going to be only as strong as its weakest link. That's not good. As we've seen in the last several months, especially, a lot of supply chains for critical products have moved to a just-in-time delivery model, and this can be problematic. This has been made possible by increased automation, better ERP systems, international logistics, and it's amazing. It's amazing when it works properly. However, it's subject to failure when any one component stops functioning. There's a million things that could go wrong with the supply chain in any industry, and we've seen almost all of them happen in the last several months. Natural disaster, pandemic, business closures, political strife, tariffs, raw material shortage, and that's just the beginning of the list. So, I mean, how many of you have had trouble buying toilet paper at some point in the last few months? That's a supply chain problem in action. Blame the supply chain. So, you can't necessarily prepare your business for every possible supply chain problem. In fact, as you know, most of the people at this conference, a lot of you probably don't care. You might shrug it off as not really being your responsibility. Your responsibility is to make the designs, make them good, make them work, technically speaking. But you don't really care about the supply chain and making sure that it's maintained. That's someone else's job. However, when you wake up to the email at 1 a.m. from your CM in Asia with this subject line, you're probably going to wish you spent a little more time understanding your supply chain when you were in the design phase so that you can avoid things like this, because they do happen. And I'm sure a lot of you have experienced them. So, like I said earlier, by definition, one link in the chain is always going to be weakest, but it should not be you as the design engineer. So follow these steps and you won't be the weak link. Assemble a list of components that are going to be the hardest to replace if there is a supply chain issue. Do this early in the design phase. Work with your distributors on contingency plans for those parts. If there are single source components that are super critical, you might want to just plan to always have a stock of those that's larger than your stock of other components to give you time if you need to design in a replacement. When it's feasible, implement the design in such a way that these parts could be replaced with some amount of engineering effort. If there's firmware or software involved here, work with your software engineering team to build hardware abstraction layers to minimize the effort that will be placed on them to roll in a new part later. So let's say you're designing in a sensor, like a time-of-flight sensor or something. You might be designing in one particular one that has a very particular footprint. But if you design the software around that in order to pull out abstracted data up to the application layer that's just telling you, okay, time of flight, the distance is X, as opposed to bringing up the API directly to that specific component's I2C commands or what have you, it's going to be way harder to drop in a new part later. You're going to have to rip out and redo huge parts of the software stack as opposed to just replacing that one hardware abstraction driver layer. And then the last thing is understand your production forecasts and ensure that you have a written copy of end-of-life terms from the manufacturer distributor for your key components. So if there's any component that's super critical that like it has to be single source, it's going to be really hard to design a replacement in, go into this with open eyes, understanding what the end-of-life terms are. Are they required to give you 12 months notice end of life? That's great. Make sure you have it in writing, and then make sure that you have an understanding in terms of the technical effort involved, how much time is going to take for you to design a replacement if you have to. If it's longer than 12 months, then you might need to give this a little bit more thought. Okay, so let's recap. 1, remember that humans need to interact with your designs. This is the most important thing I can convey to you. And again, if you've listened to any of my other talks, you've probably heard me harp on this several times now. 2, build communication bridges to the people that help you build your designs. There's no point in having 5 intermediary steps between you and your contract manufacturer or your fabricator. There's no problem with involving those people, but you should be involved too. If you're going to be paying a distributor anyways, use their services. They give you value-added services. You're not paying them just to transfer a component from the component manufacturer to you. Different distributors have different capabilities, different sets of field application engineers who have expertise in certain areas that are there to help you with your design because they want to win that socket and want to supply it to you. And the last thing is avoid being the weak link in your supply chain by considering the implications of your component choices. Think about this stuff early and it won't screw you over in the end. Okay, that's it. Thank you very much for listening to my talk. I'm looking forward to taking questions from everyone. Feel free to visit my website, jeremyblum.com. If you're interested in Shaper, shapertools.com. Ping either of us on Twitter or Instagram. I really encourage you to check out the Shaper Tools Instagram if you want to see the types of things that people are building with Shaper Origin. It's super cool. I love looking at our Instagram feed every day. And as a reminder, I have a second edition of my book that just came out. You can check out exploringarduino.com if you want to learn more about product design as it relates to embedded software and embedded hardware development. Thanks a lot.